Hi everyone, welcome back. Today we're doing day 11 two-dimensional arrays in C++, and this will be used to build on top of our existing knowledge of one-dimensional arrays. For this question, we're given a 6x6 two-dimensional array, and for each of these cells that belong to this array, it consists of a number from -9 to 9. And inside this 6x6 grid, there are 16 hourglasses. Each hourglass in this case represents a 3x3 grid, but we only pay attention to the first row, third row, and the second row's center element. So there are 16 hourglasses in A, and let's take a step back at why there are 16. So if we take the top left corner of each hourglass as the pivot point, then we can see that the possible pivot points are really the first 4 rows and within the first 4 columns. And that's because if you take this pivot over here, what you see is the current hourglass is highlighted with all the ones that are there. So this is the current hourglass that you get. But if you shift this pivot point to the third index or the fourth element in the current first row, then you can see that this 3x3 grid is really your hourglass here. And what this means is that if you shift your pivot point one more to the right, you can see that your hourglass will be out of bounds. So similarly, if you move this pivot point down to this fourth row or the third index column, then in this case, we can see that we can't move this down any further because otherwise, similarly, you'll be out of bounds. So in short, this 4x4 grid over here that I'm highlighting are really the valid pivot points that you have for each hourglass. And each pivot point represents to one hourglass. And that is why we have 16 hourglasses. Our task is to iterate through each of these hourglasses and get the maximum hourglass sum that is found among these 16 hourglasses. So that's pretty much it for this task. If you are curious how each of the 16 hourglasses look like, you can take a look at this schematic over here prepared by HackerRank. But with that, let's get started. For this question, we are very lucky that HackerRank is nice to give us the boilerplate to read in the 6 lines and pass that into a vector of an integer. So what you can see is this vector of a vector of integer, a two-dimensional vector, is defined on line 14. For each of the lines that we have on the input, HackerRank proceeds to read them in using a for loop and get each corresponding line into a temporary string variable. This is then split by a new line character, by a space character, and we get a vector of a string. And each of the items inside these vectors of string is then casted into an integer with stoi, and that is populated into this 6x6 vector. So that's pretty much it. In short, by line 30, we are already having the vector of an integer, and we can focus more on getting each of the hourglasses at each pivot point and get their corresponding hourglass sum. So with that, let's get started. Before we start, I'll be defining 2 steps that we'll be using at each pivot point that we iterate. So to be specific again, the pivot points that we have are these 16 cells that I'm highlighting. So for each of these pivot points, we have to get the corresponding 3x3 grid that is the hourglass for that pivot point. So to do that, let's define a quick function that returns a vector of an integer. And to be specific, this output would be of size 3x3, corresponding to the size of the hourglass. And let's call this getHourglass. This function will take in 3 parameters. First, the 6x6 grid, and the second and the third is just the row and the column of the pivot point. So let's call this a constant of a vector of an integer. We're making it constant because we do not want to mutate this vector, and we will pass in the reference of the grid. So the grid is the 6x6 grid that we read in. The next one is the integer, and this is the anchor row, and the final parameter is the anchor column. And that's pretty much it for the first function. The second function will take in this hourglass returned by this function, and that will return back an integer corresponding to the sum of the hourglass. So over here we get hourglass sum, and this will take in a constant of a vector of an integer. And this input, let's call it hourglass for better readability. And that's pretty much it. So now that we define the two function signatures, we can proceed to use it over here just to give more clarity to our current approach. So we are going to use two for loops to iterate through the 16 pivot points that we have on the first 4 rows and the first 4 columns. So let's use a simple row integer inside the for loop. Let's assign that to 0 first, and we will iterate through the first 4 rows. So in column equals to 0, column less than 4, column plus plus. And on line 33, this is the logic that we'll be using for knowing what to do with each pivot point. So the first step will be to get the corresponding vector of an integer, our hourglass, and let's do this by calling the function that we defined earlier. So at this point, we haven't defined the function, but we know that the behavior of this get hourglass function is just to get the hourglass, so that is fine. So the first step will be to pass in the array, and the second is the row as well as the column for the current anchor point. And once we have this hourglass, we can pass it in to get the hourglass sum. And we will be using the second function to get the hourglass sum. We will pass the hourglass in, and that's pretty much it. The next step would be to keep track of a max hourglass sum variable. Let's assign this to -9 multiplied by 7. And the reason is because each cell inside this 6x6 can be at least -9. So what this means is the maximum possible hourglass sum is really -9 multiplied by 7, because there are 7 cells in an hourglass. So at each of these pivot points, we will update the max hourglass sum by setting it to the max of itself as well as this current hourglass sum. So by line 41, if we see out the max hourglass sum, which is what we need to do for the output, this should give us the right answer. Now that we are done with the min algorithm, all we have to do is implement the 2 steps of the functions that we just defined. So let's get started. The first function that we're going to define is the get hourglass function. So this will be returning a vector of an integer. The name of this function is get hourglass. The first parameter in this case is a constant of a vector of an integer. In other words, the grid itself, as well as the anchor row and the anchor column. So now we can start implementing it. To do this, let's define a vector of an integer. Let's call this an hourglass. And this vector is currently empty. To get each of the sliced rows, for each row that we iterate, we can do for row equals to int row equals to anchor row less than anchor row plus 3 because we want to iterate through 3 indexes, and in this case row plus plus. So for each of these rows that we have over here, we will proceed to form a new vector of an integer. We'll be making a copy of this existing grid, but only get the first 4 columns starting from the anchor column. So let's call this sliced row, and this sliced row will be equals to grid row begin. This begin function will give us the iterator for this current row, the start of this current row. But because we want only the next 3 elements inclusive of the current anchor column, we will be adding this with anchor column plus and start slicing from the beginning of this row from the anchor column, and we will set this to grid row. Sorry, this is grid. Yeah, this is actually, yeah, correct. Yeah, this is row. So row dot begin plus anchor column plus 3. So with this, we will get the first 3 column elements from this given anchor column over here. So once we are done, we can just take this hourglass and push this current slice row inside. And with that, at this step, we get the hourglass and we can return this back to the call of this function. So now that we're implemented with the first function, the next is to implement the max hourglass sum function. So that will return back an integer, and this will be get hourglass sum. Let's call the first parameter vector of an integer, and let's call this an hourglass. So for this hourglass that's given to us, let's get the sum of this hourglass. So let's define an hourglass sum integer and initialize that to 0 first. Next, we will just iterate this row and column. Int row equals to 0, row less than 3, row plus plus. For int column equals to 0, column less than 3, column plus plus. We will just do if row is not equals to 1. In other words, if it is not the first and the third row, then we will proceed to add every single element in that row. But if it is not if the row is not equals to 1, then the only time where we will add that element into the hourglass sum will be if the column is equals to 1. So that's pretty much the condition for adding the existing cell into the hourglass sum. So that would just be hourglass sum plus equals to hourglass at this row and column. So that's pretty much it for this implementation. We'll return the hourglass sum, and that's all. Let's run this against some of the sample test cases. This pass. Let's run this against other test cases. And there we go. To be frank, getting this right on your first try is really common. So personally for me, it took me a few tries to get this right. So if you find trouble completing this question, don't worry, with multiple practices, it is very likely that you'll be able to do this with more precision. So with that, I hope that this question gave you some insight to how you can create a copy of another vector. So to be specific, if you wish to create a copy of a given grade, but from one index to another index, you can define a new vector, and inside the definition of this new vector, you can pass in two iterators. So in this case, this begin over here will give you back an iterator pointing to the beginning of this row. And because we want the elements from a specific column, all we did is add the current column index to this iterator. And this would point at, for example, let's say if you want the element at index 1. So adding 1 to the beginning of this row would point the iterator to exactly this element. And notice that we are doing anchor column plus 3, so that means at 1, so the iterator will be here, plus 3, 1, 2, 3. Notice that the second parameter would be exclusive inside this sliced row, because the sliced row really contains only these 3 elements here. So I guess this is a core concept for this question. And the second concept is how if you want only 3 specific rows, you can define a 2-dimensional vector and just push back this slice row and iterate from your anchor row that you want plus 3, and you would get the final result of slicing a 2-dimensional array. So I personally found this concept the most useful from this question. And I guess this is another practice of how you would get specific elements inside a grid into a final result. So I would say these two functions are really the core of this whole question, and I hope that this practice was of help to you. If you find this useful, please give us a like and subscribe, and we will see you in the next question.